only useful to use if you're using containers in production, but I would contend for most people in an enterprise situation, it's mandatory. I'm going to try to do a 1-hour deck in 30 minutes, so this is going to be rushed. So I've been working on Kubernetes and open source since 2015. I work for VMware as a software engineer on open source. The agenda today is we're going to talk about the container image lifecycle. Let me get right into it. So the way you typically use containers is that you would develop these things as a developer on your desktop, build your Docker file into images, publish it in something called a registry. The typical example of this that most people are familiar with is Docker Hub, but there are others, and that we're going to talk about one of the others today. Then in production, people would take instances of this out of the registry, pull it, and run it on production servers. And it isn't necessarily a one-to-one. One person might typically publish it, but hundreds of servers could be running that workload. So getting consistent, immutable, reproducible deployments isn't as easy as some people might think. You know, you build and deploy from Docker files. These could be viewed as something like a programming language where a skilled individual writes these, indicates what the desired outcome is. They effectively are built, or let's say compiled, into these images. Now, just because this source code in the Docker file is static doesn't mean the end result is. There's lots of potential issues here. So if I just said it's from a Ubuntu base image, it's going to pull from Ubuntu latest, but every time Ubuntu comes out with a new release that's pushed to Docker Hub, this could be changed. So, and the subsequent steps in building that Docker image also are subject to variations based on what's going on both in the outside world and on that system doing development. Why does image consistency matter? Well, because you need to get valid, consistent results through the full life cycle of software development so that what the developer tested on his Works for Me desktop is the same thing that QA tested, and then once QA has validated it, you have some assurance that it went to staging and production that it is the same thing. Otherwise, why bother testing it? So this consistency typically involves version control, other things like submitting issues and tracking them, troubleshooting, auditing, and if you don't have a consistent image even in the repository, you end up with snowflakes you might not even know about, where you've got 10 production servers all running a different thing. They say all snowflakes are different, right? That no two are alike. So even though superficially, if you don't get out the microscope, they look similar, if you really drill down, everyone is absolutely unique. So,
we do that all the time at work.
yeah. So one of the interesting issues that you can do with Harbor is actually deploy multiple registries to support your full life cycle, where the developers could push these images to a dev registry. The QA people take it from there and then republish it in a second registry that is staging, ready to go into production. And you can have governance on this, and I'll cover this in detail in slides to come. So there are other security issues in deploying containers as well. The way that containers work with the Docker runtime is that what your container runtime runs on top of Linux, and it shares a little bit more than what you might be used to in a hypervisor like vSphere, where every instance of the VM is running its own independent OS. When you run a container runtime, those container instances, you can run more than one container at a time on a host. It takes the host's Linux kernel and reuses it for each of these instances of the container as it's running. There are Linux features like namespaces, C groups that provide some level of isolation. And in theory, if Linux was 100% bug-free, it should never be possible to knock it over through any runtime code and get back to this underlying base image and do anything evil. And I'm sure you know that Linux has been around a while. You know, it's way over a decade at this point, several decades, I believe. At this point, it should be solid, right? People have been working on this for so long that we must have found all the bugs and fixed them. Well, let's look at the actual data. This is an interesting graphic put up by somebody named Keys Cook, who has gone and taken every Linux release and looked at the historical average of it. And you know, often you find these critical security flaws years after really the code was put in. Nobody knew about it, but suddenly it's discovered later, but they've been living in there as kind of latent defects for years. And the actual data indicates that these defects, they're ranked in criticality, like the reds are really bad, the yellows are still bad. And even as Linux is moving from releases in the 2 series up to the 4 series, there's no real evidence that tells you that this thing, as they're adding features, is something that's finally been put to rest and that you've got nothing to worry about. So it is possible the code that you're running in a container, especially if you're potentially getting third-party containers where somebody might be consciously engaging in malicious conduct to try to break that barrier and get down to the root, going from one containerized application or service down to the root, corrupting it and working its way back isn't something you got to worry about. Even if the kernel didn't have issues, your containers typically use third-party libraries and things. If you've been around, there was a well-publicized bug in the OpenSSL library a few years back that resulted in patching to just about everything in the known universe from what I saw, and OpenSSL is just one of these parts. So you don't only have your own code to worry about, you've got third-party code in the Linux kernel. So what can we do about it? I mean, there are security databases tracking those things in third parties, but even the third-party components you use, it isn't enough. When you deploy your own in-house code in these container images, you might be concerned about that code staying in-house, that there's no vector where this can leak outside your organization by publishing it in an image repository and then having it go from there to other sources. You might also want to impose within your organization restrictions on who can get to these images. I mean, if it's a financial app, is there really a need for people in non-financial departments to access this image? Is there a need for developers to directly go to that repository where these things are being run and be able to update them? Or do you want some governance on it where the developers first have to publish it in a development image registry, and only after somebody signs off on that update does it move upstream closer to production? So what you've got is a situation where you've got different rules for different people, different rules for different departments and roles, and you'd like to have this integrated with your own existing LDAP or Active Directory rather than try to maintain shadow permissions, because at scale that never works. So the aspect control issue is that you want to assign people into different groups, admins, developers, guests, with different abilities of being able to push and pull from these image registries. Anything down to they can read, write, to they can't get to it at all. You also want to impose signing restrictions so that you have some provenance on who actually put this in the organization, when did they do this. So it turns out that the Harbor registry is built on a service called Notary, also open source, and Harbor engages in vulnerability scanning, and this happens if you turn it on at multiple stages. So you're familiar with antivirus, where it might scan binaries as they're being written to your storage, and maybe once again as they're being loaded to memory and run. The Harbor image repository can do something similar of scanning for known vulnerabilities when you push it to a repository, then periodically scanning again on a configurable basis, potentially rescanning as those things are being pulled. And these are all based on configurable vulnerability databases. It has the ability to track provenance, where you can give it information on who's authorized to sign things and who must sign things to use these images for various purposes. The vulnerability scanning is based on the open source Clair project. It does static analysis by using these databases. These are well known. Some of them are published by governments, some by private agencies or private companies. And this is extensible, and you get to configure it. So you list the CVEs that you want to be used in the vulnerability scanning, how often the scanning should occur, and you've got real flexibility there. Ultimately, you know, you could go with your production container users pulling images right off Docker Hub off the internet and putting them in production. Or you could go with something like Harbor that has security scanning, auditing, permissions, audit logs that will tell you retroactively where these things went and when. This comes down to a choice. There's a well-known event near Las Vegas called Burning Man, which is this picture here. If you want to run on the scale of Burning Man to Stalin, where one guy gets to make the rules and executes those who violate it, you can choose where you live. I would contend that if your data center is run like Friday evenings, you've got people running around doing their form of chaos engineering, you know, intentional allowing faults, is that they do micro doses of acids, pull out random servers, light them on fire, and chuck them out a 6-story window. Don't use Docker Hub off the internet. If you want something a little better, you probably need to move up this line. And Harbor is configurable, so it doesn't mean you have to be this. It means you get to choose, and you get to choose independently by department and purpose within your organization. Some other cool features. Whoa, what happened here? Okay, it turns out that the category of image repositories or image registries is a crowded space. There's more than one choice here. So you've got Harbor, Atomic, K, Docker DTR in the enterprise space. This green column is kind of standard features you're going to find in all of them. But there are some features that you really need in enterprise deployment that not all of these have. So security scanning, the ability to deploy your own private registry, and you want it private. I mean, if you're publishing your own code, if you want somebody vetting what containers come off, you know, what services, containers, software comes off the internet and we're going to allow to be used, you can still pull it off Docker Hub, but you have an optional step here where you're going to have somebody in your organization who has to sign off that, yes, we agree to use this. And signing is another thing to consider. This signing isn't always about security. Some of this open source stuff is subject to licenses, kind of these GPL licenses, where if you use it, your organization potentially has liabilities or obligations. So you might not want free-form usage. I'm getting the 5-minute sign, so I'm going to rush along, but the deck is here. I'm going to give you a link to download at the end. I want to make sure I cover all the features. Replication is another cool one that most of these other image registries don't have. I can deploy multiple instances of Harbor, even hierarchically. Why would I want to do that? Well, massive scale. If I've got a server farm with thousands of servers, I don't want them all hitting on one registry as they're deploying images. If I'm geographical, I've got data centers all over the world in public clouds and on-prem. I can potentially configure this replication where I push it in one place, and Harbor itself takes care of this moving around the world for me, cutting my operational expense. I can put these behind load balancers for resiliency. So if one of these goes down or needs maintenance, they're all shared behind a load balancer. So this replication is a really valuable feature. This has got easy to use web UIs. I mean, we all like to think, hey, I'm hardcore DevOps, I live on a command line. But trust me, if you get that call at 3 in the morning and you're half awake, that quick overview dashboard can be really useful. It has audit logs so that when it finds a vulnerability issue, it's like antivirus where sometimes you find out about this, but it's in there for 2 months. I might want to know what servers did this ever go to so that if Wall Street is going to discover this, I can tell people, look, it was only on 0.01% of our servers in these 5 locations, so we think we're cool. It's got high availability issues if you deploy it on vSAN. How do you install it? Well, these are the components, and there are a number of them. There's Helm charts to do this, but it does have an underlying database that stores a lot of these things. That said, there are a number of install issues. I'm going to leave you with this deck so you can find these links here. I'm not going to try to cover install. I don't have enough time, but it isn't that difficult. I think if you've done it once, you could probably do another one in 15 minutes. If it's your first time and you're really reading over this carefully, maybe an hour. Here's the install procedure. I'm going to caution you that it changed. It transferred from VMware to open source to the CNCF recently, meaning a couple months ago. So really old install blogs you find, like year old, they probably won't work. So there's a sell by date on these, and get fresh ones. There's links to a couple here. How do you use it? Well, if I had time, I'd give you a demo, but it's just like using Docker Hub. It's really no different. You still do a Docker login pointing to your Harbor registry. You do Docker pulls, Docker pushes, Docker tags, just like you were using Docker Hub. No changes. There is a running server online. Sometimes it gets overloaded, but if you just want to drive it around the block, there's one already stood up, so you don't have to install it. But if you have some resource, I'd encourage you to install your own. This is a screenshot of a demo showing that UI. So it did the vulnerability scanning. This is much better than command line. It shows you what these are. You can click on these and actually see in an image what this thing discovered for you. So this kind of stuff is very usable even by rookies. This is open source, and a lot of people are skeptical about open source. These are the metrics I like to use. And Harbor, basically, I would contend by the open source metrics, it's got 20 plus independent users, meaning companies at this point. There are 110 contributors from 25 companies, and this is based on data within the last month. 112 merged pull requests, so that means people have submitted changes, meaning they're enhancing it or fixing bugs 112 times in the past month. By typical open source standards, this is an Olympic grade athlete. I mean, some open source projects sit there stagnant for a year. You never know what you're going into, but I always like to look at the GitHub stats. This thing is like going up at a super high velocity. There are a lot of companies behind it all over the world. This thing is solid. So where do you go to get more? GoHarbor.io will lead you to the GitHub repository. These are some curated resources. Whether you like GitHub, blogs, videos, get this deck after the links in the next slide or the one after that, I forget. There are online meetings, so these use the Zoom tool. Here's a link to the online meeting. They've been going at about a weekly cadence. There's a user group forum where you can submit questions, people answer them. There's also a developer group. If you want to work on it, if you love some feature, you think your enterprise is so unique that you want to inject your own really cool thing, have at it. There's a real active developer group, and we're welcome to have new contributors. The Harbor channel on the CNCF Slack, you get your information here, and come on board there as well. And these are my contacts. Take a picture of this, and this is the deck. All the links in that, it's a PDF with live links to everything you saw here. If for some reason you want to track me, this is the group in VMware's website that I work for, and I wrote a recent blog, not on Harbor, but on using Kubernetes at Edge, and for IoT applications, and part of that blog indicates the likely desire to use your own image repository. Thank you very much. I'll hang around if you've got any questions.